Okay, this comes from Chapter 10 Practice Test. So question number 10, find the measure of the angle of the triangle shown below. Find the measure of the angle A. Okay, so what we know about triangles is that the sum of the interior angles has to total 180. So measure of angle A plus the measure of angle B plus the measure of angle C has to total 180 degrees. I know B and C, so I'm going to plug those in. So I've got A plus 110 plus 32 equals 180. And now I can just solve this for A. So adding these two together, I have A plus 142 is equal to 180. And then let me fix that there. Now I'll go ahead and subtract the 142 from both sides, and we will end up with A is equal to 38. So 38 degrees is the measure of angle A. Okay. Let's see, so the next one on our list here, we've got number 29. Okay. So for number 29, we're asked to find the area of the figure below. So this doesn't fit one of our regular shapes, like a square or a triangle or a trapezoid. So we're going to have to break it up into individual pieces. So take your, like I said, I'm going to go ahead, if I kind of cut it across right here, then I end up with this longer, thinner rectangle. And then I still have this other piece. It looks like a square, but it isn't necessarily, I'm saying it's not drawn to scale. All right, so what I know about this long side here, that's 17 centimeters. And then that's this side here. And then this short side is going to be 4 centimeters. Okay, so now I can find the area of this rectangle. And then on the other one, I've got, this piece down here, which we're told is 4 centimeters. And then this side here is going to be 13 centimeters. And so again, I can find the area of this rectangle. So my area of the entire figure is going to be the sum of those two. So I take remember that the area of a rectangle is length times width. So the area of my longer, shorter rectangle is going to be 17 times 4. So that'll be, let's see, 68. So I get 68 square centimeters. And then working with the other rectangle, I've got 13 times 4, and so that'll be 52 square centimeters. So adding these two together, my total area then is going to be 120 square centimeters. Okay, so if it's an unfamiliar shape, like I said, break it up into pieces that you know how to find the area of. So, and let me just make a little side note over here. If I wanted to find, let's say I have a square, and then inside of there I have a circle, and I want to find the area, between those two. I want to find the area of this, this shaded area. Then what I would do is I would go ahead and I'd take the area of the square and subtract from it the area of the circle, and that'll give me the area between the two. So if you're combining them or adding them, putting pieces together, you'll add, and if you're looking for the area between two figures, then you're going to go ahead and subtract.
If you drive 5 miles south, then make a left turn and drive 12 miles east, how far are you in a straight line from your starting point? Okay, so let's draw a picture here to help us visualize this. So I'm going to go ahead and start right here. So that's my starting point. I'm going to go ahead and drive 5 miles south and then make a left turn and drive 12 miles. So right here is going to be my stopping point. That's the end. And the question is, how far is it from my starting point to my stopping point if I were to go in a straight line? So that's the length that I'm looking for. Notice that I've drawn a right triangle. So Pythagorean's theorem should be coming to mind. Now remember that Pythagorean's theorem says, a squared plus b squared equals c squared, where a, b, and c are sides of a right triangle. C has to be the hypotenuse, and then A and B are the other two legs. So for this particular example, the hypotenuse is x. So we're going to have x squared is equal to, and then the other two sides. So I have 12 squared plus 5 squared. And this is the equation I need to solve for x. Okay. So following our order of operations, make sure that you take care of your exponents first. So 12 squared, get 144, and then 5 squared, 25. So now we have x squared is equal to 169. And so x is going to be equal to the square root of 169. And we end up with x is equal to 13. So if we were to go in a straight line, the distance from our starting to our ending point is going to be 13 miles. Let me know if you have any other questions.
So question number 30. The rectangular front of a house measures 29 feet by 31 feet. A rectangular door on the side of the house measures 6 by 5 feet, and then there are also 7 rectangular windows on the front of the house, each measuring 4 by 4. How many square feet of siding must be needed to cover the front of the house, not counting the area covered by the door and the windows? Okay, so essentially we're being asked to, find the area. So we're asking how many square feet. So, and then I want to cover, so the front of the house. But then I'm not going to cover the doors and the windows. So let me go ahead and draw a little picture to help visualize this. So I've got this front of the house. Like I said, that's going to be 29 by 31. And then I've got a door somewhere up here that's going to be 6 by 5. And then I've got some windows. And like I said, I end up with 7 windows, and each of them is 4 by 4. So what I'm going to do to find the area of that front minus the the door and the windows, so I'm taking the area of the front, and then I'll subtract from that the area of the door, and then also the area of the windows. Okay, so my total area then, so the area of the total front is going to be 29 by 29 times 31 feet. And then the door is a rectangle, so length times width again, so the area of my door will be 6 times 5. And then I also got to subtract the 7 windows, so I'm going to have 7 times, and then each window is 4 by 4. Okay, so now it's a matter of multiplying and then subtracting these values. So I get 29 times 31, I get 899. Minus 30, and then let's see, that's 16 times 7 minus 112. Okay. So 899, I'm going to take these two together first, so minus 142, and so we're going to end up with 757. And then our measurements were all in terms of feet, so this is going to be square feet. Area is always going to be square units. If you're looking at length, whether it's the diagonal, the perimeter, those are always going to be linear, so like feet and inches. Area, surface area will always be square units, so square feet, square inches, square centimeters. And then volume is always cubic. Cubic inches, cubic centimeters. Question number 31. A parking area that is to be resurfaced is shaped like a trapezoid. The bases are 80 feet and 100 feet, and the height is 50 feet. What is the cost if the price of the resurfacing is $1.25 per square foot? Okay, so the main point is here is we are trying to find the cost of of resurfacing. What we also know about the cost is that it is $1.25 per square foot. So what I need to find out is how many square feet need to be resurfaced, and then multiply that by $1.25. Alright, so we are looking to find the area of a trapezoid. And so checking out your formula sheet. And again, there's a lot of area formulas on there, but trapezoid is the only one with the 2 bases. So you should be able to pick that one out. So it's going to be 1/2 the height times the sum of the 2 bases. Okay, so in this particular one, we are told that the bases are 80 feet and 110 feet, and we're also given that the height is 50 feet. So I got all the pieces I need. So area of our trapezoid is going to be 1/2 times 50 times 80 plus 100. Add together what's inside the parentheses first. So I'm going to get 1/2 of 50 times 180. And then you can do it all at one time. I'm just going to take half of 50 is 25, so I need 25 times 180. And then plugging this into my calculator, I'm going to end up with 4,500, and this will be square feet. So that's my area. So now moving on to the cost. Like I said, the cost is going to be $1.25 per square foot. And I have 4,500 square feet. So multiplying those two together, I'll end up with 5,625. So the cost will be $5,625.